If you have one of these old Super 8mm projectors, you probably know how much it costs to replace a bulb. So in this project, I decided to build a bulb adapter so you can use a cheaper bulb in place of the more expensive bulb. So let's go back to the computer and I'll show you how it's designed.
We need to talk about safety in this project. There's very high temperatures that exist in here when that bulb is lit and you're playing your 8mm film. We're building a socket adapter for that needs to be able to work within those temperatures. I have measured with the halogen bulb in place temperatures of 100 plus Celsius, which is pretty high. So doing a little bit of research, I found that there is something known as the heat deflection temperature, or HDT, and that determines when a material would actually warp or deflect, bend, start to melt basically when it's under load. So looking at some of the materials, I found that PLA started to warp at around 54 degrees Celsius. ABS at around 98 degrees Celsius, and nylon carbon fiber at about 150 degrees Celsius. So obviously, you need to take all of this into account when you go to print your adapter. I did print mine in ABS, but that's because my printer is limited to basically PLA and ABS. To print nylon fiber, you should look at going online to get that printed for you if your printer won't support it. So be very wary, maybe even scared of the temperatures that can exist inside this device. The last thing you want to do is start a fire or maybe melt it inside your old projector and damage it. All right.
Okay, so the first step in replicating or creating a custom bulb was figuring out how it plugged in using the socket. So I took measurements from the original bulb, and from those measurements I went into Fusion 360 and laid them out. If you've never used Fusion 360, I highly recommend you get it. It's free for hobbyists or students. Anyway, it's awesome. So what I did was I went and I took those measurements, and then I did what you call basically extrude. I extruded the pieces, and through the process of extrusion, I started to build out what we needed. Notice that on the bottom here, which you really can't see, I know, but it's keyed, so it only goes in one way. So I then added the key, went through and made some adjustments to it by creating some fillets so that it was nicer looking and rounded and not as sharp edged. And then one of the issues that I found out that I had was getting the alignment right. So I actually went and I took a photo of the plug. Let me see if I can get this where we can see it. So I took a photo. Let me turn off the bodies. Yeah. So I took a photo of this. And from that, I saw this is the key location. This is where the power is coming in. This is the AC power. This is just structural. They're not, I mean, you can put pins in there if you want, but they're not actually connected to anything. And using this as my model, I scaled it to the body I had created. So then if we look at the bottom here, you can see that I actually got the, let me see, the key. There's the key right there. Let me make it straight. So then I went in and drew the key, and now you can see it won't fit, but then I went in and made some adjustments to it. So now it fits. So that was a real key, pardon the pun, that was a real trick to getting this to work, because I was doing a lot of guesswork and it just dawned on me, take a photo and lay it on top. So when it's all said and done, we end up with this piece. Now, there's also a bulb here. I really haven't, you can basically through Master Car, within Fusion 360, you can go to the Master Car site and download drawings for certain things. So I looked for the bulb, and sure enough, they had it. This is the bulb. They probably have the socket too, but I haven't done anything with that. And I was going to use it to test the size of this hole right here, but I didn't really need to. I made a few modifications and didn't have any issues. But that would be a smart way. You can actually tell Fusion to put this, within this hole kind of thing. My understanding is pretty basic, but I'm learning stuff every day for Fusion. Then once you've got your design, you can go in and tell it to do a 3D print, and you can send that 3D print to a file, which is actually what I did. I went into the other room where I keep my 3D printer and was able to print it. And we ended up, and we'll go over to the electronics bench, and I'll show you how you put one of these together. But this is the part right here. All right, well, with that, the STLs so that you can print one of these are available. The link should be down below in the video. Let's go over to the bench. I've got to show you how you actually put one together. All right, some things you're going to need to put this together. Going to need some heat shrink. This is the MR16 connector. This is our halogen. Note that it says 21 volts, 150 watts. And that is exactly what the original bulb was 21.5 at 150 watts. This is AC, by the way, that's going through that projector. Obviously the 3D printed part, if I didn't say that already, we're going to use some super glue, and I like to use baking soda as a hardener. Basically what it does is it turns the concrete with some super glue, and we're going to use that to put the legs in place and keep them from moving. The legs, I'm actually using the legs off of a diode. We're not going to use the diode, we're just going to use the metal legs. They're stiff and thick. This is a 1N 5822 diode, and that's pretty much all there is to it. So the way this thing goes together is this sits inside here. This plugs in, the bulb plugs in from the outside. Let me show you how that works. It gets pushed up so that the little clip legs are pretty much against the plastic. And that's what's going to allow it to fit. These are going to go through these holes. And then we are going to solder them in place with the pins. It's really a simple project. So what you want to do is you want to put your MR16 clip through and be able to bend it up like that. So, give yourself a little slack here too. So maybe you can always give yourself more than you need. So you can kind of see where I cut mine. Let's see, right there. So now what we're going to do is we're going to strip those, and we are going to clip the legs off of the diode. Okay. Now we're going to clip the legs off the diode. We are going to wrap a leg around each wire. I just kind of like do this with it. And then I'll come in and hit it with some solder. Since this bulb is getting AC, it doesn't matter. There's not really a positive and a negative in this case. But I want to be able to solder this. That's not bad. That should work. Yep. And then we'll do the same to the other one. Looks like I'm going to have to move that back into place. It's probably very hot now.
Looks like I got a straggler there. I'm going to cut that off. We're going to cover this anyway with heat shrink. But I just want to make sure these are good and on there. Okay. Get yourself some heat shrink. You probably only need one piece, and you can even cut it in half. I'll slide the heat shrink over this, exposing more of the leg, because we're going to need to push the leg through. Okay. Let's go ahead and hit it with some heat. Okay, now we need to place each of these into the appropriate hole. Those are kind of marked. They have little circles on top. We're going to push it through. We're going to push it through. Hopefully you can see what I'm doing. I'm pushing them through the holes. Yep, there we go. Now I'm going to pull out some of the slack. That's fine. Okay, so now that's almost done. What we need to do is leave about 8 to 10 millimeters of leg sticking out. So that's a little short, but it'll work. Okay, so now what I'm going to do, this is the interesting part if you've never seen it, I'm going to take some baking soda here. I've got it off to the side. And I'm going to pour it in and pack it around. They actually use this, I found out about this for fixing guitar frets. I thought it was a really neat idea. So what happens is you hit it with some super glue, hopefully there's some in here, and it dries immediately. Okay, I'm going to need some more super glue. Let me see if I've got another container. 1 second. All right, so dollar store actually sells super glue. $1.25 now, I believe. And you get 2 of them. I always try to keep some handy. Okay, so basically as soon as this stuff hits, it starts turning everything into concrete that's around it. It hardens the baking powder. Creates concrete, basically. It's amazing. I'll show you in just a second when I'm done. So I'm kind of trying to soak the whole thing. I think I over-soaked it even. You can kind of look up inside there. And again, this is how they fix frets. Frets are constantly getting worn as you play a guitar, and this actually creates a concrete. It's actually a pretty good trick. Of course, you could use like an epoxy or something else. It's just what I chose to use because I use it often for things. Okay, that's all there is to it. So if we take the halogen bulb and we were to push it in, push it back a little bit, now it will actually fit into the projector and it will work. This one is printed in ABS for heat, more heat sensitivity. All right, so let's go over to the projector and I will show you how you install it. Okay, so let's talk about how you're going to put these in. It's pretty simple. Once you've built one, all you need to do is take your new halogen, push it as far back as it'll go so it's as flush as it can go, and then you're going to push it in. It's keyed, you'll feel it get keyed, and then once it's in place, it'll light up.
Okay, I told you how important it was to pick up the proper material that had a proper HDT so that you don't have warpage from the heat inside the projector. Well, let me show you something. JLCPCB does 3D printing as well as PCBs. This is something new they've started to offer. And I'm going to show you just how cheap it is to get the right material. So if we click on the website, we click add the 3D model, and we choose the same model that I'm going to give you, and we take a look at it. You have basically, right now it's only $1, but it's going to change. You have a choice between MJF nylon or SLS. I looked up SLS, and that seems to have a dimensional stable temperature of 182 Celsius. So if that's correct, we choose that, and now we see a price of $2.33. The shipping to the United States through DHL is about another $17. So you're really looking at $20 for this part. But when you add that plus the cost of the bulb, which I've seen them as low as $10, I think I paid $14 for my bulb, you know, that's a lot cheaper than a $100 DLG bulb. And this you can use over and over again. So anyway, I just wanted to point this out to you, that it's a good way of getting some 3D parts that you might want. Thanks a lot. Remember to subscribe and learn something new every day. All right, guys, take care.